Hello and welcome to part 2 of a personal history of Unix, Linux, files and processes. And when we left off I said I'd mention files. Well, we will. But first, a little bit about Linux. So let's jump in. Linux, and there's this wonderful penguin. Why a penguin? Well, there's a story behind that. Linux was developed in the early 90s by a gentleman named Linus Torvald. And here's a younger picture of Linus Torvald sitting with a Sony netbook. Torvald wanted to build an operating system that he could use to run a small device that he had. His bookshelf behind him is kind of entertaining. There's a number of things in here that really piqued my curiosity. Some of the books that he has, I have copies of and have had for some time. In particular, there's a book here that you see I've got my mouse cursor on Linus's right eye. If I move it over here, you'll see this yellow splotch underneath this book called Linux. Well, let me show you something here. That yellow splotch is this book, The Design and Implementation of 4.3 BSD Unix Operating System. And you can see that if I hold it this way and pull it back towards the camera, there's this wonderful little devil here. There's a history of odd furry animals populating the operating system's mascots. Ken Thompson had an ID badge at Bell Labs that seen in a couple of pictures that were taken of him. He had not his picture, but a picture of the furry creature Gizmo from the movie Gremlins. And it wasn't Gizmo in his polite mode. It was Gizmo in his nasty mode. So anyhow, there's a history of this kind of nonsense that floats around in the Unix and Linux environment. And Torvald is notorious for the penguin because he had a visit to the zoo and from what I understand had an encounter with the penguin that the penguin may have won that encounter, but it's neither here nor there. However, the penguin is the mascot of Linux. So now that I've discussed Linux to no effect whatsoever, let's talk about what makes Linux and Unix different. Basically, Linux was created because the GNU project, who had worked on building an operating system that was Unix compatible. In other words, it could use Unix shells, it could use Unix programs like VI, ED, copy, sed, awk, those types of things that we'll talk about later in this course. GNU had started that project in '83 and hadn't come up with a Unix compatible clone yet. This code for Linux is open source, unlike Unix, which is a closed source code. I mentioned that quite a bit of the kernel in Unix could be created using C code. The thing is, with the Unix distribution, you don't get the C code, you get the compiled kernel. There is nothing that you can impact on that kernel. The kernel comes done. So it's open source, which means the kernel is uncompiled. Basically, it comes to you as C code, and you can twiddle it as needed. It also can be read. Torvalds built his kernel in '91, and he would have used the GNU kernel if it had been available at that time. So what really separates Unix from Linux? I think a good spot to start here would be talking about Mac OS X, which is a Unix operating system. It came out of that BSD, the Berkeley Software Development or Distribution. What separates Mac from, for instance, an Ubuntu is the drivers for the Mac hardware are optimized for that hardware. That is proprietary code that is written to take advantage of every possible speed and feature of the hardware that's in the Mac. They do it really well. The various Unix systems have their own flavors of file system code. They have specific drivers, that type of thing. For instance, with the Ubuntu that's running on this Samsung laptop, I don't have access to the quality of drivers for various pieces of the hardware. For instance, the sound that's available on this thing that would be there, for example, a Windows distribution, because the hardware makers will write their drivers based on the predominant operating system, and the predominant operating system is Windows. It's not a Linux distribution. So there are some differences, but Linux was built to look like, not be, but look like Unix. Linus Torvald did not have access to the C code that built a Unix operating system. He built an operating system that had the functionality of Unix, not a line-by-line compatibility to Unix. So that's one of the differences. So the kernel in Linux interfaces directly with the hardware, and you've got to have specific device drivers and more, and these are written by volunteers often. From there, you need a Windows desktop environment. So there are various flavors. Wayland, Mur, KDE, X11, and GNOME, for instance, are there. Layered on this are various shells and applications. So you can get things various places from there. There are multiple Linux variants. Red Hat being a very important Linux variant in the enterprise. CentOS, which is owned by Red Hat, it's basically Red Hat. In fact, we used to use CentOS in our training at IBM. There is at least one file that you can go in and modify and make any other software think that CentOS was actually Red Hat, and it won't go any further than that. There's SUSE, which is Software und Systementwicklung, German, of course, Fedora, Ubuntu, and Debian distributions. And Ubuntu is basically a Debian distribution. One of the things that makes Linux really stand out in the enterprise is another product. When the original IBM PC came out, one of the things that was talked about making the PC popular was something known as a killer app. And the killer app for the PC was a spreadsheet. And it was Lotus, and later bought by IBM. But the killer app for Linux, in particular Red Hat Linux, which is a supported Linux, is VMware, virtual machine. Basically, with the virtual machine, what happens is you have a piece of hardware that may have 16 to 24 CPUs and 32 to 64 gig of memory. And you split that machine into smaller virtual machines. And each one of those machines has a Linux image running on it. What happens on machine A does not impact what's happening on machine B. In other words, they look like completely different machines, completely different hardware environments, even though it is a single machine. So those virtual images, those virtual machines are out there, and that allows you to build multiple standalone Linux images on one single machine. And that really has done wonders for the takeoff of Linux in the enterprise. And speaking of Linux in the enterprise, let's do this. Let's take a quick peek at this video.
You use Linux every day, whether you know it or not. Over 850,000 Android phones running Linux are activated every single day. Compare that to just 30,000 Windows phones, according.
Well, isn't that special? Hang on. We'll come back to this. Yeah. Let me get out of this here in just a second. We'll come back to it. Get that out of the way. Bring that up.
According to the latest reports.
There we go.
That means 100 Android devices have come online just since you started watching this video.
Actually, more.
Nearly 700,000 TVs are sold every day, most of which are running, and financial trades are powered by Linux. 9 out of 10 of the world's supercomputers run Linux. Google, Twitter, Facebook, and Amazon are all powered by Linux. So, how is Linux developed to achieve all of this? Unlike other operating systems, like Windows or iOS, Linux is built collaboratively across companies, geographies, and markets, resulting in the largest collaborative development project in the history of computing. Just since 2005, about 8,000 developers from almost 800 companies have contributed to the Linux kernel. These contributions have resulted in 15 million lines of code, 1.5 million lines written in just the last couple of years. Consider that Homer's epic Iliad poem is a mere 15,000 lines of text. The novel War and Peace, just 560,000 words. But it's not just about the sheer number of lines of code. It's also about how quickly Linux is developed and released. For example, a major new kernel comes out every 2 to 3 months. Compare this to years for competing operating systems. This is made possible by a unique collaborative development process. When submitting code to the Linux kernel, developers break changes into individual units called patches. A patch describes the lines that need to be changed, added, or removed from the source code. Each patch can add a new feature, new support for a device, fix a problem, improve performance, or rework things to be more easily understood. Developers post their patches to the relevant mailing lists, where other developers. When the patch is close to being release ready, it is accepted by a senior Linux kernel developer, or maintainer, who manages one or more of 100 different sections of the kernel. While this isn't a guarantee that it will go to the main line, it's certainly a good sign. Here it gets an even more extensive evaluation. When the maintainer finishes their review, he or she will sign off on the patch and send it on to Linux creator and Linux Foundation fellow Linus Torvalds, who has the ultimate authority on what is accepted into the next release and what is not. Nearly 10,000 patches go into almost every new release. About 6 patches are applied to the kernel each hour. Linux's rate of development is simply unmatched. Today, Linux is dominating on mobile devices, in the enterprise and web infrastructure, data centers, supercomputing, and more. What's next? Because together, we're ready.
Notice what it didn't say is Linux is not on the leading in the desktop, and that's partly because of what we talked about earlier, device drivers. Some of the odds and ends that have to be done to make it work well. Windows in the desktop and Mac on the desktop, even though Mac's more expensive than most of the Windows devices. Pretty much have the home user and the enterprise desktop locked in. Something that I heard earlier is that one of the things that makes the Windows desktop so good in and so prevalent in the market is the ActiveX directory. I haven't really spent much time looking at or trying to understand the ActiveX directory, but I think that may be something that I need to do.
We interrupt this lecture to bring you the following important announcement. The old guy did not mean ActiveX, he meant Active Directory. ActiveX, after all, is the Internet Explorer equivalent of plugins, while Active Directory has an analogous feature in Unix Linux known as LDAP. We now continue with your regularly scheduled lecture.
But Linux is a good tool. You're going to be using on the ats-cis.jccc.edu, a CentOS implementation. I'd like to show you, and I think I'll bring up the terminal window here and show you this, uname-a. This is a request. If I go back and I do something called man uname, this is a request to print system information. And a dash A is print all of the system information. So let me do a Q uname dash A. This tells me what's going on here. This is a Linux distribution. It's running on a machine called Brownsburg, which is that Samsung laptop that I have. It is the 4.2.0-22 Linux generic. It is an Ubuntu release, in this case 15.10, which I showed you in part 1. It also shows you when that distribution was loaded. So one of the good things about Ubuntu is they come out with a new version of the kernel twice a year. And I last loaded a new version of the kernel on December 17th. At least twice a year they come out with a new version of the kernel. So the last update was December 17th, and that was at 10 o'clock UTC. In other words, UTC being Greenwich Mean Time, which is about 4 o'clock in the afternoon my time. Actually, it was about 3 maybe o'clock in the afternoon. The other information that kind of floats off the end of the line here is x86. Well, it's a 64-bit x86, so it's an Intel type hardware device. And it's GNU Linux. So it is part of that open source Linux, and it is as much as possible POSIX compliant. So here we are, which Linux? So on Brownsburg, as you saw earlier, I had a 3.13 version of Linux running on that, and you can see that was loaded on August 13th, 2014. And then if I can blow this up just a little bit, and we'll go down here. Yep, come back here. This was at one time what was on ATS-CIS. And notice it's just a plain Linux kernel, it says, but in reality it's CentOS. So let me get back to fit page. There we go. And we'll go from there. So let me shut this down. We'll start back up. We'll talk about processes and files. So we'll see you in just a bit. This ends the second segment of week 2, a personal history of Unix, Linux, files, and processes.